Good morning. I am Luis Alfonso Dañez, and today I will be presenting you some problems involved in the introduction to spectroscopy, which is the learning task 2. So, before we move on to the problems, let us first recall some of the formulas needed for these consecutive problems. So, review of formulas needed for these problems. So, for the first formula, we will be using the Beer-Lamberts law. So the Beer-Lamberts law is consisted of the logarithm of transmitted radiation all over the incident radiation, wherein it is equal to the negative ABC, wherein A is denoted by the absorptivity, the B is denoted by path length, and C, the concentration. And then the ABC is equal to capital A, wherein the capital A is denoted by the absorbance. So using various formula relationships, we can derive that A is equal to the absorbance is equal to the product of absorptivity times path length then times concentration, or the capital A is equal to the epsilon times B times C, wherein the epsilon is denoted by the molar extinction coefficient. So we can either use the two of these formulas, A is equal to ABC or the A is equal to epsilon BC. Uh, the A can be substituted as epsilon, which is dependent, which can be dependent on the problem given. So it depends whether you're going to use A or epsilon. So the second formula that we're going to use is the linear regression formula. So this can be used if you have a set of data which is only represented by two variables, which is the x and the y. So let us move on for the problem given number 1. So the absorbance of an unknown permanganate solution is 0.5 at 525 nm. When measured under identical conditions, a 1 times 10 to the negative 4 molarity permanganate is found to have an absorbance of 0.2. So the question is, what is the concentration of the unknown? So the hint is to use ratio and proportion. So before moving on to the solution, let us first give the given. So what is the given in the problem? So for the first given, we have the absorbance of the unknown sample. So let us represent this as a sub 1. So a sub 1 is equal to 0.500. Then the concentration of the known sample, which we are going to represent it as C sub 2, which is equal to 1 times 10 to the negative 4 molarity. Then lastly, the absorbance of the known sample, which is represented by A sub 2, which is equal to 0.2, 0.2. So then, the required, based on the problem, is the concentration of the unknown sample, which is the C sub 1. Now, maybe you're asking, there is no P, then there is no A, the small a. So, for the solution, using formula A, capital A is equal to small a times small b times small c, wherein A and B is constant. Since it wasn't given in the problem, the A and B, but we can tell that they are constant because it the problem said that they are measured under identical conditions. So, instead of finding for A and B, we can use the ratio and proportionality method. So, representing A sub 1 is equal to small a sub 1 times b sub 1 times c sub 1. And it is proportional to the absorbance of the unknown, which is the a sub 2 times b sub 2 times c sub 2. So therefore, by using the ratio and proportionality method, we can tell that the absorbance of the unknown sample over the absorbance of the known sample is equal to a sub 1 times b sub 1 times c sub 1 all over a sub 2 times b sub 2 times c sub 2. Then since a and b is the small a, then the small b is constant, we can now remove the a and b, the both a sub 1, b sub 1, a sub 2, b sub 2. Then we are left with a sub 1 over a sub 2 equals c sub 1 over c sub 2. By transposing and leaving the concentration c sub 1 on the left side, we can derive that c sub 1 is equal to a sub 1 times c sub 2 all over capital A sub 2. So this is the formula in order to find the concentration of the unknown. Then by substituting the given, we can tell that 0.5 times 1 times 10 to the negative 4 molarity all over 0.2 will be equal to 2.5 times 10 to the negative 4 molarity. So that is the concentration of the unknown sample. Moving on to the problem given number 2. So problem. The determination of iron in an industrial waste stream was carried out by O. Fenantroli. Using the data shown in the following table, determine the concentration of iron in the waste stream. So this is the data given below. So this is the time that we will be using the linear regression formulas. Why do I say this? We can tell that from the table, there are only two variables, which is the concentration of the iron represented by ppm and the absorbance. So these are only two variables. From the two variables, we can either label them as x and y. Now with the given x and y, we can now find the summation of x, summation of y, the standard deviation of x, standard deviation of y. We can now find the slope, the intercept, until we can have an equation. So for the given is the concentration of iron in ppm, which we are going to label as x values, and the absorbance, which we are going to label it as the y values. So for the required, which is the concentration of unknown, given y value, wherein y is equal to 0.269. So for the solution, in my own version of my solution, I used the Microsoft Excel 2016 in order to come up with this answer. So what I did was to just plot the points, plot the data given in the table. So concentration as x, then the absorption as y. Then by using a graph, I used a graph in order to visualize and to represent the linearity of the given data. So by plotting and visualizing, we can say that this is a perfect straight line, because we can see that the r squared is equal to 1. If it is equal to 1, then we can tell that it has a perfect linear relationship. Then um, I the the equation was derived by using the method of the Linus method in the Excel. Then after using the Linus method, uh, I observed that the slope of the line is 0.1817. Then the intercept is 0.0006. So by using the slope and the intercept, we can tell that the equation is y equals 0.1817x plus 0.0006. Then Using the equation y equals 0.1817x plus 0.0006, we are going to substitute y for 0.269. Then, by substituting it, we have 0.269 equals 0.1817x plus 0.0006. Then, after transposing all the variables and the equations, we come up with 0.2684 equals 0.1817x. Then dividing both sides by 0.1817x, we have came up with the value of x. So x is equal to 1.477. So with the given value of an observance of 0.269, we have come up that its concentration is equal to 1.47 ppm. So that is all, and thank you for listening. If you have comments, then you might want to drop down some comments in the video below if there are questions you want to ask. So thank you.